Welcome to another unit in this methodology toolbox. This time I'm going to talk about exponential smoothing. Exponential smoothing, that's a method you can use if you have a data set, usually if you have a time series data set, and on the one hand you're aiming at determining the overall development of your data set, of your time series, with the main goal in mind that you can do a prognosis later on. So if you know what the main drivers of the development are, you can actually use them to model the next step. So in this context, there are three different approaches to exponential smoothing, which all build on each other. So all of this starts with the exponential smoothing of first degree. In this case, we assume there's simply a level. So there's an overall constant and we follow this level. So the forecast basically is the next value. And that's actually pretty easily done. We assume it's the mean. And then we continue the mean indefinitely, assuming it will always be the mean. Well, that's obviously not so good a method if you want to do a forecast, especially since most time series are a bit more complex. That's where exponential smoothing of second degree comes into play. Here we also have a level, but we also have a trend. So in other words, we basically assume in this context that our development follows some kind of straight line. That's as if we were using linear regression to find the line and then more or less continue along this path described by our straight line. That's how we get our forecast in this case. Finally, the most sophisticated version, also in some cases referred to as the Holt-Winters method, that's exponential smoothing of third degree. Here we have the level, the trend, and we have some kind of seasonal pattern. Seasonal pattern, this could be anything from only 1 month is much stronger than the others, but well, it doesn't always have to be month. There could be a seasonal pattern, for example, every 6, 7, 5, 80 seasons. That doesn't matter. Here we first need to determine this pattern, and then we assume this pattern is repeated over and over again. Well, at this point, I just argued, okay, we have level trend with second degree, like with a line. We have the seasonal pattern which comes on top of this. This is just one version to work with exponential smoothing. That's called the additive approach. We can also have some kind of multiplicative approach, which assumes that, for example, with the second degree, we do not have a straight line, but more or less an exponential relationship. With third degree, this means that the fluctuations described via the seasonal pattern become either more pronounced or less pronounced over time. That's the idea of multiplicative exponential smoothing. And that's basically everything I wanted to mention in this short session on exponential smoothing. So I conclude this with nice greetings and see you next time.